Yo, happy Friday. Safe Stefano, how are you? Welcome. It's more AQUABOY. I'm sad it's the end of my week off, or week on AQUABOY. My week off work, my week on AQUABOY it's the last day. It's Friday, but it's Friday. Fridays are nice, aren't they? Weekends around the corner. So let's dive straight in. Sparkly water, that's what we're doing today. Yeah, not still. This water is rather sparkling. I'll show you where we're at. The charged cables do now charge the water, which is pretty cool. Oh yeah. So that kind of all works. Oh, come back here. Yeah, there we go. Bit tired. Take it slow today. Nice. It doesn't hurt yet. No, we don't have any player health stuff in flux. I want full damage too. And in the long run, there's gonna be other things that can damage you, fire and enemies and things. But yeah, so this is fine, and then this is fine. But you see how we get like a performance hit now. And also you'll notice that I can't turn it off. The power should be coming from it. Once I turn this off, it should all turn off. It's all being charged from that button. But there's a feedback loop occurs. Once this cable gets powered, it then starts to also power the water, I think. But yeah, it works. Like, it works to set up the circuit. It's just once the circuit is set up, there's some horrible loop happening that we need to fix. And then yeah, like, it doesn't. Okay, well that works. But like, one thing I can show you, look, is that like, if we unplug this now, the water just stays charged even though there's nothing charging it. And also this cable is also just staying charged even though it's no longer plugged in or anything. So that's bad. Trying to like drop both ends of it. Okay, it's quite hard to do. Anyway, I can probably drop both ends of it over here. I think both of these cables are broken at this point. I think if we pull this one entirely out of the water as well, yeah, it's still just powered forever. So yeah, so it's cool. It is cool, and it's going to be great. And the water should act as like a splitter as well, so you can power a body of water and then have 3 or 4 cables coming out of it that are all powering things. So YouTube is to do that in real life. Wait, what? With cables and water? That sounds like a do not try this at home moment. I do feel like I should make viewers aware. I'm not condoning doing any of this in real life. So we've just got to get our head around it, but I think the part where it goes wrong is here. This is where we're triggering things happening with the pins. Electricity getting trapped in wires and making infinite electricity. Surely not. That's jokes. So what we do is we say, yeah, this is fine. This just controls when we're underwater and when we're not. They're fake, of course, right? Okay, yeah. Infinite electricity sounded slightly too good to be true. The problem stems from the fact that these cables have a polarity to them. Either pin A is the end that is set up to receive, or it's set up to send power. So the wire has a send and a receive node, and then it simulates the wire. And these get paired with one of the pins, depending on which direction the electricity is flowing. And as it stands, that's something that the water and the pin need to be aware of when they're kind of working this stuff out between them. The water itself now has a power reset timer, so every 0.2 seconds we like turn the power off on all the water, and then we check every frame for new connections. Or we check that the connection is maintained, I suppose, is what's going on. So the pin doesn't know whether it's sending or receiving power in any given case. The pin needs to know this. The wire knows, because the wire has this bool to say which side of it is the sending side. Pin A is send. Could it help to distinguish between something that is live and something that is actually generate? Because when we lost the generator in the chain is when we need the power down right. Yeah, exactly. So that's what I mean about the send and receive. If the pin that's in is sending, then we don't need to power that. Then the water should never power that wire. The water should only power wires that have a receiving end dangling into the water. But I think there are 4 cases. Let's draw the cables as an arrow, okay? So there's this case. There's this case. There's this case. And this case. And I'll show you what I mean. Hold on. So the water is here in this one. Here. Here. And here. So a cable has like polarity when it's plugged into a socket, and that because the sockets also have a polarity to them. The socket will either be like connected to a button, for example, which is powering the socket. The socket is therefore like a sender socket, or the sockets can be like little receivers that power things like a door. But for a cable to have polarity, it must be in a socket. So you have these 2 cases. You have that one, or you have that one. That's the 2 different ways that a cable can be in a socket on one end and in water on another. And actually, I don't think we care if the socket is underwater. For now. I mean, that's actually a question, though. What sockets do when they're underwater is another question. I think a socket that's switched on should power the water, too. So we'll have to get to that. Anyway, or you have this case where the cable isn't plugged into a socket on either end, and it's just one end's in the water and one isn't. And then you have this case where, but I think with both of these, nothing happens because the cable isn't powered or powering anything. So the water doesn't need to interact with it. Water only needs to have, it only needs to care. Actually, no, that's not true. I think if this end isn't plugged into anything, then the water should override and say, well, because you're in water, then you're kind of plugged into me, and make it into the water should force this into a receiving end and kind of prep the cable for doing this. Because if the player then picks up this end and plugs it in, something like this, that will override, and then it will give it the arrow that we want. When both ends are underwater, it doesn't really matter. One end, arbitrarily, one end just is receive and one is send. It just doesn't matter at all. There are other cases. Let's draw some more. There's the ones where the plug is underwater. So if the socket is underwater, that's a situation. there's the receiving socket. It goes to like a door or something. When that's underwater. And then I think what we want to say is just like catch all. Any socket that is actually plugged in while it's underwater. I think that should be just like this, I guess. I guess it just doesn't matter. I guess it just behaves like one of these two, whether it's plugged in or not. I think Minecraft Redstone does it a bit simpler, where only certain blocks are active, like a redstone block, while a redstone wire simply has a power value but isn't active. Yeah. That makes sense. I was talking to another friend about this last night, who was saying you don't want all these different things to be passing the state around. You just want to have the generator, which in this case is just the switch on the wall that generates all the power in the first instance, and that's it, and then everything else just passes that on. Which is kind of what I thought I was doing, but I guess I am kind of passing like the powered state through everything, and then like causing these long chains of updates when something happens. But I think we're quite far down this road, and it is making sense to me, I think. So I'm gonna stick with it, because we're so nearly done with all this stuff. It really is just this the water stuff to go. But I think these are all the cases that we need to prepare for. Whereas at the moment, what I have is just these two. I just say, like, look, if you're underwater, if you're powered, send it, and if you're not, check if you can receive it. And it's not as simple as that. So it shouldn't be just if you're powered. It should be if you're powered and if the pin let's write this guy a nice little function to check what role it's playing. Or we give it a variable and we have the wire kind of constantly updated. Yeah, let's do that. Let's do it that way. So this pin will be underwater, but it will also have a variable of is send. And we'll set that by default, I think, to... wait, hold on. We don't probably want it to have a default value. Because... A bit volatile and sometimes rewrite midway. Yeah, I've done that a few times with this project already with different things. I think we're far enough down the road with this though, and it is working really reliably for everything but the water. And the player already does this. When the player interacts with wires, we have to do these kind of just checking which direction things are flowing in that wire, because the wires can be used in either direction. So the player just updates the wire like, yo, look, I'm plugging you into this, and now you're flowing this way, now you're flowing that way. But the water isn't doing that. And the water isn't considering any of that, and that's what the water needs to consider that stuff. So that's all there is to it, really. I guess we'll have them default to false for is send. So that means like a cable that hasn't been plugged into anything at all will they'll just both be false, right? Both ends will be false. I think that should be fine. And then if a wire starts unplugged, pin A is send is true. So if a wire starts unplugged, then we'll just set pin A to send. Okay, so then that matches with the default value there. So even though both pins have this script that start as false, we'll match it with the main wire script to make pin A send by default. Also, I'm thinking in this case, specifically, the way you traverse the data or the info propagates is more important than how the data itself is represented. Yes. This is just all about logic, right? So I've tried to keep it compartmentalized by having the wire separate from the pin and separate from the simulation and all this stuff. But anyway, so that sorts out the initialization of any wires that start unplugged. Then so that's default for them. Okay, that's cool. Shouldn't one of those two wires have editable children? I don't understand. Is it because socket 2 has the wire in it there? Right, I see. It's plugged in like that. And then, yeah, I remember. Okay. So it must come from the socket then, does it? Yes, there it is. I'm trying to remember, assume it's all connected. Where is the part in the code that knows we're now disconnecting the power socket? Because that's where the responsibility is, I feel. I think all that bit's working. because it works when we don't have water involved. The problem is that the water is repowering the circuit backwards. The water's kind of got a way in to like force power through the system in the wrong direction by just indiscriminately powering the cables that it plugged into it. Here, where is it? Here. This is the problem, is that anything that isn't powered can be powered by the water. And there's a slight delay on how often we depower the water. So the socket, right, when it starts, if there's something plugged in, then these are all the things we do. We start the wire simulation, which is cool, and then we plug it in. So we always start by running this thing, and we detach the other pin, making the other pin fall down. Yeah, the way I think that I'm planning to do it is to make the pins more strictly one directional with how they, because the pin here is just indiscriminately, if it's powered it's sending power, and if it's not powered it's checking if it can take it. And it needs to know what its role is. The pin should know, I'm a sender, I don't receive. And the receiver should be like, I'm a receiver, so if I'm powered, I'm not sending that back into the water right now. I'm hoping we'll solve it. I very much hope. So I was just following that breadcrumb trail. So it's the plug-in is happening, which is cool, and the plug-in is here, which means we make the wire do the plug-in thing, and the wire plug-in thing is here. And then this is where we're setting the pin numbers. So it's in here where we then want to say, like, okay, if pin A is send and that's true, then let's tell pin A that you are send. Yeah, so this is the part of the code here. So then we just do pin A dot is send. We're kind of like doubling up our variables here, which is a bit dumb. We could probably get rid of this one now. Pin A is send equals false, and pin B is send is true, and then those be the other way around for here. Oh, because this is in wire, so we need to get them from wire sim, don't we? Where? And then there's other versions here where we need that one and that one. I think that's all pretty good. I wonder if we should attempt to get rid of all mentions of this now. Let's see how so we've got that first declaration of it. We've got those 4, and then we do 2 checks. And that's it. What about in the wire in there? There's nothing in there in the wire sim. No references to it in there either. In any of these other scripts. 2 matches in the socket. Okay. And none of these states are going to have it mentioned in. Okay, so I think it's just 2 scripts where we can get rid of it. I would be nervous about just replacing everything. I think I can get rid of this though. And then therefore this and this. Let's take that and copy it. Oh wait, I don't need to do that, sorry. We can just get rid of that mention. Get rid of that mention. But here, this row, if ysim.pin8 is send, cool. And that is cool. Replaces that one, we save, and then in the socket, let's just hope everything works the same as it always did at this point. Okay, it does look good. Still looks good. Yeah, I can't turn that off now. That's classic. Maybe you can with one cable, that's cool. Okay, I think everything's still working. I think we've done that. We've successfully refactored that. And now it's the pins themselves that know whether they are sending stuff or not, rather than the wire just having this one bool to say which one's the sending end. Now both individual pins know what they are. And now, if the power that you're a part of is powered and you're the sender, then send power. Elif not is send. Newt. This, I think, should improve things drastically. I don't think it will solve every potential error, but I think it might resolve a few. And it didn't work out. I didn't stop that one. Oh, it did then, but not here. This cable is broken. Is this cable going to be infinitely powered? So it's not quite perfect. We've made the two statements much better, but we're still not doing this. We really don't want to have two separate variables that mean the same thing, because they may end up not agreeing. Well, if I only ever set them in a pair, which is what I've done, right? The only times we're ever changing any of those variables, we're setting them in pairs. I mean, apart from when we initialized it, but that's because we're just moving one of them away from the default. So the other one would always be the opposite to it there. Because that's if they start unplugged, the other one's going to start as false, so that one's going to be true. All the other times we set them in pairs, contradicting each other. They're variables that only ever set in those functions there. So should be okay. It's a future problem. Yeah, well, screw that guy. Future self can deal with it then when it comes back around. So I think we're doing this every single frame. So that works. Every time we turn this off, it turns off and the water turns off. It just works. The turning off of the thing definitely works. Now, once that's in, I think it stops working. Oh no, okay. So I must have just mispressed it earlier. It is just the turning off of this guy. Check power. Right. So let's have a look at this, because I think the other thing is that the water check power doesn't... If the current frame's water position is powered is true, then turn on. Else, turn off. That's pretty basic thing to have missed. Now this might be it. This might just work. I wouldn't be surprised at this point if this did it. My level is too large for me to test. Okay. Looking good. What happens if this is just in there? Well, now we have a loop. And then as soon as one side comes out, the loop's broken. So we could leave that in. That could actually be kind of cool. That you basically you make a battery. Why is it flicking like that? I guess because it's... Jokes. You could do it once every half a second. Do what once every half a second? Oh look, same glitch here. Well, that is interesting. And I guess that's... Was it doing that at the very beginning before I pissed around with it? Like just from the default word go. Was it flickering? No. So something happens after I've pissed about with it a bit, where the flickering begins. It's not doing it this time. Everything seems to be working absolutely fine now. So I don't know what bug I created last time. Can't remember what I did. I guess we could watch the VOD of the stream. You see a noticeable like downturn in performance when the double-ended wire's in the water. But the logic seems to all be working. I find this very confusing. There we go. I've done it. And now the flickering. And now the flickering. Okay. Interesting. You might have race conditions, different outcomes depending on the exact order of operations and how the scripts are fired. Pesky stuff to debug those. Yeah. The way I see it, I think what's happening is, I think the bug only happens when I've swapped which end of the wire with the ends of these wires. Oh, look. That's bugged out also. It was like it was bugged out because it was on the edge. Somehow. Okay, so if I pick this up and swap it around there. No. Oh wait, hold on. This is broken. This wire's broken. Because it's just powered. It's just eternally powered. We've got a few bugs still. That's a different one to the last one, damn it. So I think it's when cables end up with both ends under the water. These are the cases that are the problem. Turned that off then. Huh. So sometimes it feels very robust. Sometimes I just can't get it to do anything. Funny, isn't it? There we go. Yeah, so look, solid when they're this way around. Flashy when it's that way around. And it's because this cable's now broken. This cable's like eternally powered. So it is actually the same bug. It's when one of these eternally powered cables is on the receiving end, we get the flashing. Although we can turn that cable off, which is quite interesting and unexpected. So you get these cables that once they're in the water, yeah, okay. Well, we can debug this quite easily, I think, because we can look at the cables as they sit in here now. So which one is going crazy? So for the first wire, pin A is send and pin B is underwater. I think that quite perfectly describes this guy. And we can double check that, I suppose, because we can look at its receive node. No, look at its send node. It's targeting something. That doesn't actually support my 5265. Ah, no, okay. 5265. So actually wire 2 is the one. So is this whole this thing's actually happening because this wire is the wrong way round? If I flip this, no, we still get the flashing. So what's happened to wire 2 now? Pin A is neither, and pin B is both. Let's swap that again. Pin A is both and pin B is neither. Yeah, okay, so it's what you said, Stefano, and it's flipped. Somehow. Oh, wait, no, that's right. No, that is right. Isn't it? Because the one that's underwater is the sending one, and the one that's above the water is the one that's receiving. Yeah, so, okay, so wire 2 is working correctly, as one would expect. So we need to look at wire this one. Why is this one flashing? And this is wire 1. So it's receiving, it's sending to object 4129, which would be the door. No, sorry, it would be the door's receive node. Oh, it's not. Oh no, sorry, it would be the socket, wouldn't it? It would be the socket's receive node because it's plugged into the socket. 4129. So the wire is sending to 4129. Okay. Its receiving node is 2952, which shouldn't appear anywhere because it's a loose wire. Pin A is set to send, and it's not underwater. Pin B is underwater, but it's not set to send. So that pin B is the one that's underwater right now. Now pin B is sending, and pin A is underwater. The real issue is how can you be sure that the water is sent to this cable? Why the flicking? And now this cable's broken. Okay, let's investigate. It's underwater and it's saying no. The wire is just powered. Okay, so when we check for power, we get the wire pin, we get the wire sim, we get the wire, we do turn off. And if we do wire turn off, then powered gets turned off. So I think the pin, if you're powered and you're sending, then you can do that, right? But if you're underwater, yeah, I guess that's the question, isn't it? Is how are we checking when a cable comes out of the water? I think still not convinced you can do this without traversing the entire chain. Yeah, potentially. I think the way I did it in that circuit manner thing was that anything that generates, like, actually sends the pulse every frame and just checks the whole network every single frame. Rather than, like, triggering these state change events. I'm just thinking of loads of hacky ways of doing things that I know is probably bad. Only when the generator state changes. No, you need to do it when any state along the chain changes. Because if some new item gets added into that circuit. But thinking about it, I do want to get this right. Because there was also talk of having metal, like weldable objects that would also like carry the charge. I really don't want to have to start it all again. But it is getting tricky now. I think one of the key problems is there's no way at the moment, because I think the problem is that wires are sometimes, when they exit, when we pull a wire out of the water that's powered, look, just straight away, this is the problem. That's immediately the issue. Can turn it off while it's underwater. But you can't turn it off by picking it up and taking it out of the water. I think that's the problem. Well, that's definitely a problem, right? Like, if that's not the problem, it certainly is a problem, because that's not right. So let's solve that first, which I think we can do. The problem is, yeah, we do need to kind of go back and check right at the start where that power's come from, and are we still connected to it or not, I guess. So much blank staring into space and thinking to be done. Making TFC Reloaded. Yeah, if only. That would be fun. Safe Anis, thanks for joining us. How are you? Between the each frame script and the player triggered scripts, there's no way to predict the order. Yeah. TFC Reloaded is cool. Yeah. I spent a long time playing that game. That was fun. This is where it all begins, the switch. And it sends these signals down the chain to turn things on or off. It would be cool to make a game in the spirit of TFC. Yeah, yeah. Well, like, what's it called? Vintage Story, right? Is kind of that. I kind of think like a roguelike style thing for TFC would be cool. Some kind of caveman survival roguelike. Yeah, or 2D platformer TFC, yeah. Something like that would be fun. 2D platformer, maybe top-down 2D type thing. Anyway, let's not get distracted. I've got a puzzle platformer about a guy on a submarine to make. Yeah, do it like a Game Boy style game. Oh, when is the next GB Jam actually? Because that's the one jam this year I'm definitely gonna enter. I love that jam. Everything else I'm gonna try and focus on. And it's it's towards the end of the year, isn't it? They do it once a year. We've done very well in the last two. Gravity Boy, 6th out of 400. 2 years ago. And then last year's one. Where did we come? About 10th or something, I think? I can't remember. '20th. Out of what? Out of 400 again. Not too bad. But yeah, okay, GB Jam's like right at the end of the year. Is there a server for Serious TFC? Oh, I don't know. What's it called? Serious Firmacraft. It's been ages since I played on that server, so I don't know what the state of it is actually. I'm afraid to say. Okay. Let me just ponder this for a bit longer, because I think both problems that we've observed, the flashing and the cable maintaining power when it's pulled out of the water, is all because of the same thing. It's all because the pins don't know when they leave the water to turn themselves off. They know when the water stops being charged to turn off. If we can just get it so that they reliably turn off when they come out of the water if they're still not powered, I think we're laughing. And I think it's simple because these pins know whether they're the receiver or not. If a pin is a receiver and it's not plugged into something and it's not underwater, then the cable isn't powered. So we just simply have it check that. If not is send and not underwater And how do we check if it's plugged in or not? Is that another thing that the only the wire knows? Yeah, so it's in here. Plugged in. False by default. And then when plugin is called, because that will be from the socket when it does its like initiation thing, and it calls plugin, then it calls on the wire, which is here. Yeah. Gotta get my head back around my old code here. Yes, Rob, how you doing? You alright? So if the socket we're plugging into doesn't have a target to send to, then it means that the socket starts sending to the cable. So then the one that the player's holding gets plugged in. And this is the socket sending to the cable. So we're plugging in the receiving end. So if the player holds 0, that's pin A, so that means it's false. But at this point we're plugging in player held, right? So so whatever the weather here, because we're holding 0, did I call it is plugged? No, just plugged in. Pin A plugged in is true because that's the one we just plugged in, and in this case it would be pin B that we'd be plugging in. Okay, or well, it's different for the sending, but for the in terms of whether we're plugging something in, that's true there, and then When we unplug, we've got the same variables to add in. So, but this is quite easy because we're detaching pins. So we just know that that means that it's A that has to be changed to false. And in this case, it would be B. And in this case, it would be B. And in this case, it would be A. So now we're tracking whether the cables are plugged in or not. Fine. We go look at the pins. If you're not sending power, so if you're a receiving end of the cable, you're not underwater, and you're not plugged in, then this. Don't know what I'm actually trying to do here. Okay, so that's that problem definitely solved, which is a good one to have solved. So let's just mess around until we make another bug. Swap these cables over. In fact, let's leave that one there and just turn it on. That guy's getting a little flash on. So I bet this cable will be bugged with the flashing thing now still, which must mean that's a separate error. Yeah, it's got the flashes. And it's because this is the cable that started over here. I mean, look at that. That's the wrong end. Yeah, that's not working there, is it? That's because I've picked up a send end. Got the flashes, yeah. I think I've got the flashes too. You know, it comes down to, I think, the fact that the water doesn't have its own send and receive nodes. It's got this totally different way of working out whether it's powered or not. thought I was so much closer than I was yesterday. I think I feel quite far away from the solution now. Like we may have to rethink our whole system. I want to keep as much of the system that we have in place, but we might have to slightly rethink how the signals are sent. But something's just... The fundamental problem is to do with cables that are not plugged into anything. We need to have like a neutral state for the cables to be in, where if they're not plugged into a socket, they're in some kind of a neutral state instead of being in the whatever state they last were in. So that then we can handle cases where they aren't plugged into something. Because they don't actually need to be powered. If both sides of the cable are unplugged, all they need to do is turn green. Then it's another thing to keep up with. Yeah, it is another thing to keep up with, it's true. I'm just wondering, I think with all the variables we already have, we just need to add a third state in, because at the moment pin A is send, and we have the pin A is send and pin B is send. But then when you like unplug it, then neither of them should be send anymore. Yeah, there's so many variables, it's true. So just change whatever that means. The only thing I've got to do is look at all the bits connected to me and see if I find a generator or not. Yeah. I'm going to be remaking this whole system, aren't I? I think I am going to be remaking the whole system. Which probably means that I should commit everything I have, draw a line in the sand, and then hack it to pieces. So I mean, this isn't a bad state of affairs, but I need to go back to just like simple rooms with just one door in and stuff, don't I? copy the entire project. So basically what we could do is we could change it up so that anything that can carry signal has like a variable, a powered variable, which is what our water class has. So we'll give everything that can carry charge one of those nodes that's like we just call it conductivity node or something. So we have like a node. They all have this node which has a variable for whether it's powered or not. Okay. And then it needs some kind of a system whereby it keeps track of like an array of like connected people, connected to things it's connected to. And then it needs to have a function that like we trigger when its state changes. And that makes it check these guys. I don't know why I drew that like that. It doesn't really make sense. Oh, why is it? So we have the powered variable, which is a bool. Then we have this array of things it's connected to, and then its state change will check the array, and like there'll be generators that won't have a variable called powered. They could just have one called like powering or power. Well, it just needs to be a list, doesn't it? Because they can be connected to multiple things in multiple directions, and it just needs to scan the whole network for something that's sending out power. And then I guess anything that wants to react to power, so then it has a func like to say like tell parent if powered. The water can have 3 or more cables in it, so you really have a tree style data structure to deal with. Yeah, so I mean the array, what I mean about the array is on every individual item in the tree has an array of other nodes that it's sharing with. You could loop cables back in the same water. Yeah, it's just a graph. Yeah. So it just scans the whole graph. So I guess I could just keep one graph. breadth first search algorithm. Okay. Okay, about depth levels, I see. Yeah, that makes sense. But it is like you said about Minecraft, isn't it? It's about having a difference between something that is sending out the power and things that are just passing it along. And then I suppose you have a third thing, which is something that just receives it. And things that are sending it along are like also in this group, actually. Things that generate power also will have this, and will also potentially have this quality. Okay, think about it like this. Like, here's everything that can be powered. And then here's everything that can send power, or like pass on power. Let's call it transmit or share. Can share power. And then within that is the batteries. Can generate. I can't write with a mouse very well, but it's like this, isn't it? Everything that's involved, every node on the network, like every type of electric item will be in this group, because we'll want to give the player feedback. If something is powered, the player should be able to see that it's powered. So at the very least, everything will have a visual, there'll be a visual impact at least to whether it's powered or not. And then there are things that also have the functionality of checking when they are powered. They don't just change their own state, but they form a link to anything else that's powered, that's connected to them. And then the things that can generate power are like their own special types of things. So you have it kind of like, we'll have these graphs that probably look quite a bit like this. And I guess maybe some of those things will be linked. But it'll be like that, right? I have that connected to that, that connected to that, and that, but it's also connected to that, and that's connected there, something like that. And then how the water plays with all that stuff as well. Yeah, I think I need to go back to the drawing board. in the long run, I think it makes sense to rethink all of this, because this would be a much simpler system, and hopefully I can still reuse quite a bit of what I've got already. But probably not. I'm probably looking at getting rid of most stuff. A door socket is a conductor with only one end. You got your drawing board. Oh yeah, sick, man. That's fun. Yeah, I've been tempted by getting one of those for years and years, but I've never got around to it. But yeah, that'd be sick. I'm looking forward to seeing these the character all coloured in and stuff. It's gonna look sick. So much to think about. I mean, we are close with the system I've already got, but we're gonna be adding metal boxes into it as well. It just feels like, yeah, look, it's just there are a few, yeah. I mean, with the system we've got, if we made a state for the wires where they were like in neutral mode, it might work. Because if both ends of a wire is unplugged, it doesn't need to do anything. Both ends can be receiving ends. Always make a bug into a feature. Classic. Rubik, yes, how are you? You alright? Long time? That's what she said. I don't know. I can't remember what I said now. I'll have to take your word for it. So... yeah, performance is going to be a thing that we want to keep in line. Yeah, safe, Jason. I remember. How are you? Let's have a go at giving the wires like a neutral state for when both ends are unplugged. So once we unplug an end, and yeah, when we start it, look, we just start by making pin A send true. Let's not do that. Let's keep them both false by default. This, when we plug it into a socket, sets everything up just right. So I think that's all fine. When we unplug it here, I'm listening. About to roll out in bed for 4 minutes. Nice. So this is the thing, yes, you say if you're beat, you don't know where the power comes from. With the system I've built, you do. Because everything's got a polarity. So that's worked until now. But the water is the exception to that, because the water doesn't have a polarity. Things are just either they're overlapping with the water or they're not. And that's why we're running into problems, isn't it? Because the water doesn't have that polarity. It just has like either it's powered or it isn't. But if something plugged into a socket, then its polarity is being defined. The problem we're having is I think when cables are not plugged in. So that's why I think we need to make this third state. You would need to approximate the water as a particle simulation. Well, we kind of got that already. Look, check it out. The water kind of goes woo and does its thing, which is quite nice. So let me finish doing what I was doing, because I did remove that from there. So it's in here. You check it you turn it to false, right, when it's unplugged. So when something becomes unplugged, we have to say if, once you've finished that whole process of unplugging it, not to both, if pin A isn't plugged in and pin B isn't plugged in, then set both the sends to false. So now we force both ends to being receivers. See if that changes things. I think it might, you know. Safe, Hugo, how are you? Just curious, what happens if you have two unconnected pools of water and the wire dangling into each? No. So, I have done that. It's in the water algorithm here. When you send the power, the power like checks for the edges of that body of water and only powers the ones that are in. Is that what you mean? If you have two unconnected pools of water and a wire dangling into each. Yeah, so it wouldn't in that case because the water isn't connected. We have this nice while loop where we kind of just basically like spread out from the point that's got the power and just power everything that's touching. But it only powers that particular body of water. Jason's bringing in like actual physics. Electric charge should be a gradient along the path from the cathode to the anode. I wonder if this will work. Let's see if we can make any bugs now. Like, really optimistically, I've solved it. But probably not. Okay, that's not working. Why does it do that then? If we can get to the bottom of that bug, we might solve it all, I suppose. Now we get flashing. So this hasn't fixed the flashing. I think I need to start again with this, don't I? It hasn't fixed any of the bugs that we had before, the change I made. Yeah, I think I might start the electricity stuff again. I'm just feeling that, so I'm thinking about this. There's so many more edge cases I haven't even got to yet. I need a more robust system like you're talking about, Stefano, I think. I think there is something in this structure. You'll see the world. Well, yeah, hello world, right? Let me go to the loo. I'm back in 2 minutes. Okay. How would this particular situation, it is whiteboard time, isn't it? How would this particular situation here help us with the water? Because I think that's the problem. The water, each individual water class instance that makes up our grid, each one of these has this powered state. So if I'm imagining this system where each node is in one of these three tiers, right, of functionality. Every conducting object has an array of unqualified connections. They're all the same. Everything is water. Yeah. The difference is you don't want the water itself to be behaving like these objects are. If you can find the generator you want, that's what I'm thinking. But this system requires then the water to, and I don't need to model the polarity. I do think getting rid of the polarity will massively help. That was my like big idea, to make it simple, which I think to an extent it does when you're dealing with small circuits, but as you scale it, that makes it more complicated. The thing I'm struggling with is we don't want each individual piece of water to be a node on our graph, because there's too many pieces of water and the graph will be enormous. We want to still maintain this kind of sending power across the whole body of water in a flash, and kind of basically having each body of water deal with itself like it's one node. We want to treat the other nodes slightly differently to water, so that the whole thing doesn't scale up massively, because the water is lots of different pieces. But you reason in the same way. Yeah, sure. So the water can still do all this stuff and change whenever power. But then I don't want to be triggering this send power as such. If we go down that other route, then it's structured differently. Yeah, that makes a lot of sense. Connections and disconnections can happen when the water moves, though. So whenever water moves, you got to do that every, so often. So water triggers the connect and disconnect, yeah. Yeah. Am I chatting on Discord at the same time? No, so I'm streaming to Twitch and YouTube at the same time. So I've got 2 different chats that I'm responding to, Jason. So yeah, it's a little confusing. I need to sort out the thing so that both the combined chats appear on the actual stream. That would be cool. Yeah, I think I might call it a day for now then, because I just need to sit and think about all of this a bit more before I make my next move, I think. Hopefully lots of what I've made can still be used, right? It's just about the logic behind it. But I think the send and receive nodes are going to go and just be replaced by like just a power node. I'm wondering if everything can have this one script, because then I can just have like export variables that sort of cross or tick off the various levels. Well, I suppose that one's always a tick. Anything that's got the thing always has that. The question is it here or is it here? Safe, Jason. How you doing? That's why you think we should store the events and only run the checks every once in a while. Yeah, okay. If I can just think about how to do this, but still treat the water as one big thing. Because I suppose what you want to do can each water particle store an electron density variable? How about new? They can store powered as a bool. And that's it. I mean, it is fun to see what it's doing so far. It's pretty fun. Alas. I do think starting again is probably the thing. So See, that's wrong. That's... If we could fix this. That would be cool. I'm gonna get this phone call. Burb. Alright, we're back. By the way, while water moves, only the connection to that body of water needs to be updated, not necessarily the powered state of the entire circuit. You actually need to simulate water connections in every possible state, or just in pools of water. Trying to get my head around what you mean. It's just that because the water can form part of the circuit, whenever the water moves, the circuit is potentially changing. The way I'm thinking you would do it, because we have this ability to link them, you make the levels. I know, but we want to build tools that allow us to make interesting levels, and I think it's important to make the tools general purpose at this stage, so that then we have complete flexibility when we make. But water particles is conductive. Yeah, we kind of have that with the power one. But I was just thinking though, is like, anytime a wire pin is in the water, it can still do this stuff. It can still send power. And if it finds, and if other wires find it, then they're connected. No, but that's the other thing, is we want the whole water body to hold the charge so that it can deal damage to the player. Okay. Oh, yeah. I'm going to throw in the towel for the day. I'll probably do more work on this afternoon. But I need to spend some time thinking, pondering my life choices. But thanks for watching, and this is definitely progress. This is one of those moments where it feels like one step forward and two steps back, but it's all moving it in the right direction, isn't it? Is it a wet towel? Is it a conductive towel? But yeah, thank you very much for watching, one and all. Happy Friday, and we'll be back for more. Maybe tomorrow. Probably, definitely tomorrow. Okay. That's that. Peace out. Ciao.